Hi, good afternoon, everyone. My name is Virginia. I'm the founder and CEO of HCStudio and Zia Technology. Both companies focus on 3D printing, material development, and also industrial applications. So I'm extremely excited for today's event, and I'm very happy to share my experience, my inputs. On about this industry. So today my topic is the application of digital design and 3D printing in customized jewelry production. Um, sorry. So in today's speak, first of all, I'll talk about HCStudio and Zia. And secondly, I'll share how 3D printing has evolved in the jewelry making history. And thirdly, I would like to show you guys some of my artworks. And fourth, lastly, some of the challenges we have been facing and also the opportunities basically for sorting the problems. So about HCStudio. So HCStudio is a company that I found in 2016. It is a printing service provider, and we make printers for complex microstructure components. So basically, it means that we are the developer of printers for metal and polymers, and also we also provide printing service for polymers, metals, and ceramics. So our typical clients include research institutes and labs. And also we sell a lot to denture factories and clinics, and also jewelry workshops and factories, and also multiple automotives and aerospace developers. So these are two models of our metal printers. They're both powder bed based printers. And we sell around 120K US dollars. So at the moment, mainly to denture factories. So most of the clients are based in Europe, Brazil, the Middle East, India, and countries in Southeast Asia, like Vietnam and Korea. So we also supply printing materials with excellent prices and also provide well-rounded after-sales warranty. So you can see the parameters on this chart next to the printers. So next, Zia, it's a brand that I found last year in 2020, which is a special year for all of us. So basically, Zia is a sustainable jewelry brand which promotes advanced manufacturing in jewelry and artworks making. So with the help of 3D printing, new materials, and lab-grown gemstones, we are able to provide, make jewelry with much greener technology. So the keywords here are direct printed end products. Also, we print metal directly, and we print ceramic directly without manual welding. So this is our website is www.zia.tech. So I would like to share with you guys how 3D printing has been evolved in the jewelry making industry. I believe this is maybe also the case for some other industries as well, because although we're making different products, but we share a lot of similarities in the evolution of industrial revolution. So back to 6,000 years ago, which is 4000 BC, we were at stage one of manufacturing, well, jewelry manufacturing in particular. So I call it the primitive stage. So at this stage, how jewelry was made is, first of all, we need to handcraft a mold. And then afterwards, we send to casting, which is a procedure that we melt the metal and then pour the melted metal into a mold. And then in the end, we receive the end product. So that was what we did thousands of years ago. And then 30 years ago, around 1990, as you can see from this chart, 3D printed technology has developed first in Europe, and then next possibly in Japan and also in China. So after having this technology, we reached the stage 2, what I call the stage 2 of modern manufacturing. And also this is the technology that we're still using right now at the present. So how we do it is that we will use 3D printers, mostly desktop printers, to produce a resin mold. It's also made with light-sensitive materials. So after we have the mold, as you can see, like it looks like a plastic, and we send the mold to casting. So after casting, we receive the end product. So stage 1 and stage 2 pretty much is the same, that we need a mold, a physical mold, and then we send to casting, and then we receive the end product. But what stage 2 has improved in here is that we no longer need people to manually craft the mold. So we can just basically draw a mold in a computer. So afterwards, we can refine the mold and then change the look of it enormous times until we are satisfied with the shape, and then we send to a printer to print. So this is stage 2. So right now, I think we are at stage 3, so which is an intelligent stage. So what we do in here, and this is also what we do in HCStudio and Zia, is that we use softwares, what we call CAD, is computer-aided design softwares, to make a mold, non-physical mode in a computer. And afterwards, we change and refine it to the shape that we like. And without needing a casting procedure, we send it directly to a printer to print the end product, and then we received what we want right after the computer design. So this is much straightforward and much faster in the idea. And this is what I personally believe will be the mainstream manufacturing method in the future. So in here, I would like to share with you guys some of our works. If you know how to draw with computer softwares, and maybe you find this information also useful. But if you're new, I would like to share with you guys. So when choosing a CAD software, so what are the characteristics that you need to focus? So first of all, I think design freedom is very important. So you need a software that can, basically every designer is an artist. So as an artist, what we want is we have an image in mind. So no matter it's drawing with hand or drawing with a software, we would like to realize what we think as freely as possible. So first of all, it's very important. And second, familiarity is also very important. We need to find one or two softwares that we found most, how to say that, so you can use it, it's to your own freedom, to your own taste. So basically, it's you get familiar with one or two softwares, and then what I would do is I would stick to them. And lastly, which is also very important, is the compatibility of the software. So what it means in here is that the software you need to keep in mind, so the file format or the nature of this software needs to be compatible with our slicing software. Well, what is a slicing software? So I'm sure some of you will know. So we need to slice an object before sending it to a printer for printing. So slicing is a very important process. So when you choose design software, you need to keep in mind that it has to be optimized for slicing software as well. So based on all of these characteristics, so I have some of the softwares recommended listed here. First, we use a lot of Rhino. So Rhino is commonly used in industrial design and art design. And then next we have ZBrush. So ZBrush is, personally, I found it very useful for details and complex structure. So basically, personally, I found it like when combining one or two softwares, such as Rhino and ZBrush, that you can get a very ideal finishing of the design. Also, 3D Max is very common in jewelry and artwork design. And lastly, we have Crayon. So Crayon is used in industrial design, such as like objects with very structural finishing. So Crayon is also recommended. So in China, as well as in Hong Kong, a lot of jewelry manufacturers, they like to use JewelCAD. Some people also call it JCD, but I personally don't recommend it because JewelCAD was developed, I think, over 20 years ago. So it used to be a very high-tech software at that time, but right now I found it not compatible with a lot of our slicing softwares. So when you basically send the file to a slicing software, there is a lot of errors of the files, that the designs that was made by a JewelCAD. So in the end, we end up using a lot of time to basically to correct the errors, and some of the errors is not correctable. So basically, so that's why I would not, if you want to use 3D printer to print out your designs, I would not recommend you to design with JCD. So I'd like to share with you some of our works. As you can see from the picture in here, this is copper and tin alloy. These are the 4 rings that we print out. As you can see, these are all the pieces before processing. And obviously, they have the characteristics of metal 3D printing, which has a rough surface and also a lot of supports, which takes a long time to remove. And also because you can see sometimes the support material can take up to half of the weight of the overall parts. So it's basically, and the supports we cannot use, we cannot reuse it. So it's kind of like a waste of material. So the Lattice is basically the name of one of our collections. So why I name it the Lattice? It's because it's the concept itself is a combination of art and science. So basically, as you can see in here, art. So lattice work, according to Wikipedia, lattice work is an open work framework consisting of a crisscrossed pattern of stripes of building material, typically wood or metal. So So Chinese lattice design is characterized by cultural symbols and repetitive use of geometric patterns. Many windows, doors of traditional Chinese architectures are generally ornamented, mostly constructed of handcrafted wood. So typical lattice patterns include ice ray lattice, lucky cloud lattice, which you can find in a lot of artworks, Chinese artworks, and also the Chinese knot that I'm sure you guys have seen it somewhere in a palace or when you do tourism in China, or if you go to Chinatown, you can see this quite often. So these are all the traditional, because I'm Chinese, so these are all the lattice that I saw during my lifetime. And also, interestingly, the lattice is also a concept that is, I'm sure you are familiar in material engineering. So when we talk about crystals, we can see it is if we actually ignore the actual atoms, ions, or molecules, and we focus on the geometric of periodic arrays. So the crystal is then represented as a lattice. That is a three-dimensional array of points, and each has identical surroundings. So these are the three typical body center cubed, face center cubed, and hexagonal close-packed lattice structure in material engineering. So I find this similarities very interesting. So that's why I created the lattice collection. So these are some of the process. First of all, of course, is design, and then we print, and there we go. We have the product. So basing on the concept, we started to. Here we use Rhino for this particular design ring, and then we use a metal 3D printer, a powder bed based printer, to print out the ring in bulk. And then in the end, we remove the supports, and then we send it to the factories for polishing, post-processing, and then we, with 18 karat gold plating, we get the end product, which is gold plate in 2 different colors, as you can see in this picture. So this is also the from the Lattice collection. We have necklaces and also rings and bracelets. And in here, as you can see, we have beautiful peonies from traditional culture. So peonies are native to Asia, Europe, and Western North America. So it is said that there are over 33 known species. So these are some of the images, some of the pictures that I draw before. So the one on the left, in the center, basically, it's I drawn it with an iPad, and then the one on the side with colored is I draw it with gouache. So the properties of peony is they're complex. They have layers and many layers. So I think first of all, the look of peony is obviously very attractive, and also I would like to have a design that can reflect the can combine really well with 3D printing. So this is so I was inspired by the glamorous Chinese peony, and also the design concept named the Chinois Sehi, which is a Oriental Rococo style from the 18th century France. So the collection features grace and femininity with accents of asymmetric design that portrays both beauty and personality of modern women. So as you can see in here, we use the design, print, product process. So first of all, we do a sketch. You can do either on iPad, which is very, very extremely convenient. I would strongly recommend for drawing, because just like Photoshop, you can use layers to draw on an iPad. So, but in here we use pencil to sketch, and then we use a 3D Max in this case to draw a ring, to design a ring in the software, and send it to, thirdly, send it to a printer for printing, and then we get the end product, which is, you can see in here, we use abstract lines to express the exquisite peony. So this is formed in a printer without any manual weldings. So this is also from the Peony Collection. You can see there's an earring and a ring, and also on the side we have this extravagant necklace. So that combines asymmetric design of peony and also layers of strands. So this necklace, it's currently in the Jewellery Museum of Shenzhen, and we display there for a very long time. And also, this is one of our work. We use a ZBrush to design a dragon, and this is a dragon ring, basically. As you can see, you can realize a lot of details using ZBrush. And also, this one is a design that one of our customer ordered. So it's called the Canton Tower Pad. So basically, first of all, we do a sketch, a design, and then we use the Rhino, in this case, to realize it in softwares, and then we send it to a printer. So this is inspired by Canton Tower, which is a landmark of Guangzhou city in China. So this is a unique 3D printed pen. Displays a remarkable gradient colors, which mimics the beautiful neon lights on the actual tower. I'll show you the actual tower. So this is the pen, and then you can see that's the actual tower in nighttime. So the colors on the pen were formed during oxidizing of the titanium material. So this is made of medical grade titanium alloy. So titanium is basically a very magical and material with excellent mechanical properties. And when oxidized, it will display beautiful colors. So this you can use as a wonderful piece of art. You can put it on your desk, and then when you need it to write, and then you can use it as a pen. So lastly, I would like to share some of the challenges and opportunities that we experienced in the past few years. So first of all, as some of you probably know, 3D printing metals, especially the technology with selective laser melting, that's what we call SLM, has very rough surface quality. So what it means is that it has a rough surface, and then it needs a lot of support to conduct a thermal, and also to basically to hold the piece during printing. So the support is necessary at this stage for printing, but it also creates a lot of surface roughness, because where the supports need to attach to the actual piece. So when you remove it, it's extremely rough on that particular area. So so we need to manually remove the support, which increase a lot of labor work and also time for processing. And as I mentioned previously, so most of the support materials is not reusable. So it's also a waste of material. And also, because as we often mention, 3D printing is very ideal for making parts that is not that is difficult to make in any other manufacture method. So we tend to use 3D printing to make the parts that is with very complex designs. And because of that, we need, because some of the surface, we need to put supports in it. And if it's internal, it's basically impossible to remove the supports in the internal surface of the part. So if it's hard to or impossible to remove the supports, it would be also difficult for post-processing, namely for polishing and gold plating. So so that is one of the challenge. Another challenge is that the parts are difficult. It's very difficult for post-processing. So basically, it's for the last few years, I found it very, very difficult to find professional SLM or 3D printed parts post-processing service provider. There is very little company that is doing this kind of professional post-processing. So I need to turn to traditional factories to basically do the post-processing for the parts. And because 3D printed parts, the properties is different from casting parts. So the traditional factories, they don't really have a lot of experience in dealing with 3D printed metal parts. And they found it frustrated because they are not familiar with the materials. They found it frustrated and they don't really want to process the 3D printed parts. So we experienced a very difficult time to find the right partners to, who wants to or who is willing to basically deal with our works. And so sometimes some of our pieces will sit in a factory for months, and then afterwards it just sent back in the same condition without any kind of processing. And the answer from the factory will be, I'm so sorry, we are not capable of dealing with the 3D printed parts. And so we need to look for, another factory to do the same thing all over again. And in the end, so 3D printing is supposed to be a fast process, which is a straightforward process. But because of these mentioned difficulties, it becomes something that is time consuming in the end. So many times we lost control of the processing time. So right now the challenges is also we consider it as an opportunity for the industry. So first of all, I think it's extremely important and also vital in this case and urgent to improve service quality. So which means that there are different methods, approaches to realize the improvement of service quality. So first of all, we would need to increase the printing precision and printing quality of SLM parts, possibly through smaller laser beams, possibly through finer powders, and that is a lot of scientific and engineering work for printing providers. And So if we have a better printing technique, possibly we will need less support, which will at the same time increase service quality. So the opportunities for post-processing business is obvious to me, because in the market there isn't such professional factories to deal with the post-processing from a 3D printing company. So I think this is a very good opportunity for new markets. So so last words, both Zia and HCStudio is looking for partners globally. We would like to see more people using our printers and materials. And also, if you're interested in the jewelry that we print, we're also open for cooperations globally. And we're also open for investments. So if you're from an investment institute, please feel free to contact me. And thank you so much today. I'm very happy once again to share although the time is limited, but I'm very happy to share my experience and some of my thoughts with you. And my email is displayed here, and also you can search me on LinkedIn, Virginia Wang. So thank you so much. Bye.